Hello, welcome back to the Geography 300 Geographical Data Analysis video series for WVU. Our topic for this set of videos is regression. Now, regression is probably the most commonly used inferential statistics test that is out there. And what it does is it works off of and measures something we have seen already in passing called correlation. So this first video looks at those two concepts, correlation and regression, and introduces them as a setup for the remainder of the videos, looking in more detail at the different parts of interpreting regression, how we work with it in our inferential hypothesis testing framework, presenting the results, things like that. So, as I said, the two concepts for this video, correlation and regression. So we saw correlation through the idea of spatial autocorrelation. And it was where basically our spatial autocorrelation is the value of some attribute at a place related to the value of the same attribute at other places nearby. If we strip out the spatial and we strip out the auto, we're left with correlation. And that's just looking at the relationship between two things. So are two things related? Things like as one goes up, the other goes down. Or as one goes up, the other also goes up. So to put that in a couple examples, for as one goes up, the other goes down, we could take a very simple example, in the US at least, of the proportion of the voting in a particular county for the Republicans for president, and in the same election, the proportion who voted for Democrat. As more people vote for the Republicans, a greater percentage vote for Republicans, a smaller percentage voted for the Democrats. That's what happens in a two-party system. As one goes up, the other goes down. There is that kind of relationship between those two variables. As one goes up, the other goes up. An example could be from the upcoming exam, I would hope. As the amount of time a student spends studying goes up, the grade on the exam should also go up. So there's this positive relationship. As one goes up, the other goes up. And a negative relationship, if one goes up, the other goes down. So we have, through these examples, we may be able to see a couple other general ideas that go along with correlation. So just as with spatial autocorrelation, a positive correlation is where they both go in the same direction. Negative correlation is when they go in opposite directions. And it should be noted where it may or may not have been obvious from the examples that we're again looking at the relationship between two attributes. But actually we kind of saw that with a t-test or with ANOVA. The difference here is that both variables are continuous. So when you're deciding, okay, is this something I need to use ANOVA for, or something I need to use regression for? If one of your variables is a category, then that's ANOVA. Or if there's only two categories, then it's a t-test. But if both variables are continuous, would fall under the interval or ratio data series, data type, we want regression. Now, all of this is still true for correlation, and I drew a distinction between correlation and regression. So what does regression then add to this idea of correlation? What it does is it then regression specifies things called a dependent and an independent variable. Now, okay, what's so special about these? Well, it says basically on one side of the equation you have one, and on the other side of the equation you have the other. We'll see the equation itself in the next video. Conceptually, and you can, if you ask 5 different statisticians, you probably get about 5 different opinions on this. But at least arguably, it would be setting up a relationship, not just to say, are these two related to each other, but to say the dependent variable by its name is dependent upon the independent variable. Okay, so what does that mean? In terms of interpretation, we would say, okay, the poverty rate is dependent upon income, or the average income for a county. So what that can say is the difference of opinion is whether or not you want to associate a causal relationship to this. So to say an increase in the income, could you say that causes a lower poverty rate? Maybe yes, maybe no. But it's saying, I want to, and in a way, to borrow from chi-squared, I want to use the income value to predict the poverty rate. So the other thing that we can say, whether or not you want to attribute causation, is we're using the independent variable, so named because essentially its values can just be changed independently. An independent variable being used to predict the value of the dependent variable. So these are the ideas for correlation. Looking at how closely related are these two variables? That's correlation. With regression, we go and we add in this idea of dependence, of one variable being dependent upon the other in terms of prediction, if not outright causation. Personally, I would argue it is merely with prediction. Bringing in other information, you might be able to put an argument together for causation, but just by itself, the statistics alone do not, a regression analysis alone does not do that. So, Those are the ideas of correlation and regression. What we will see in the next video is basically the different parts of a regression equation and how we interpret it, along with interpreting the results that we may get from regression output. Following that, we'll put regression put regression into the inferential statistics framework that we've been using throughout much of the semester. We'll look at some of the pitfalls in interpreting regression, especially within a geographical context. And lastly, looking at writing and presenting up regression results for a particular audience. So thank you for watching. As always, if you have questions, please speak up in the Zoom class or send me an email. Have a good one.